Hey, what's going on, guys? It is your average programmer here, and today I want to talk to you guys about the process of insertion sort. So if you don't know what insertion sort is, it is basically an algorithm that allows you to sort a collection of things, whether those things are strings or numbers. In this case, we're going to be working with numbers, and we're going to sort them in ascending order, so from least to greatest. Now, the basic idea of insertion sort is to understand that you have your first element in the array is sorted. Now, this first element in the array is its own array. Hypothetically, we're saying that. And now we've got the rest of the array here that's in black, that's unsorted. So what's in green is sorted, and what's in black is unsorted. So we want to take everything that is in black, all of these elements, and bring them over to the sorted side. Now that is just the general gist of insertion sort. So let's go ahead and see how this works in depth. I'm going to explain the process. So first, as you can see here, we've got two indices. We've got I and we've got J. So what are we going to do with these? We are going to take the element at index I, always going to take the element at index I and store it inside of this temporary variable, because there's a possibility that we may lose it in the future when we're doing shifts and comparisons. So we've got I and we've got J. J is I minus 1, which basically means that it's one index less than I. So we're going to say, is the element at J greater than the element at I? In this case, yes, it's true. The element at J, which is 12, is greater than the element at I, which is 8. So what we're going to do here, we're going to override the element at index I with the element at index J. So now the 8 becomes 12, and the 12 hypothetically becomes a whole. So we're going to use a question mark to represent a whole. We don't know what value is going to be there just yet. And each time through the outer loop, we are going to decrement J. So J becomes 1 less than it was originally. So now we can see that J is out of scope of the array, and there's no other comparison to the left that we can make to J. So we say that J plus 1 is now equal to the temporary variable. So it's safe to say that the 8 is correctly sorted. So we store 8 inside of J plus 1. And from here, all we do is we increment I and we reset J. Increment I. We are going to reset J to be 1 less than I. J is always going to be 1 less than I, unless we are making inner comparisons. And I'm going to show you that with the pseudocode implementation. So J becomes this, and we can't forget that 12 was part of the sorted array, so we have to extend the scope of the sorted array. So now 12 and 8 are both part of the sorted array. So now we replace the element at I, or we copy the element at I into our temporary variable. So now 41, I meant to write this in black, 41 is stored inside the temporary variable. So we make a comparison. Is the element at I greater than the element, or the element at J, sorry, greater than the element at I? In this case, no. So it's safe to say that we are good. So we increment I and J, J and I, and we extend our sorted portion. So now we store the element at I, remember, constantly storing the element at I, inside of our temporary variable. So now 9 is part of our temporary variable. So we make comparison. Is the element at J greater than the element at I? In this case, yes. So again, we are going to erase the element at j and override it with the, or we're going to erase the element at I and override it with the element at j. And now j becomes a whole. Again, a question mark, because we don't know if we're going to insert our temporary variable in here yet. And now we decrement j. So is the element at j greater than our temporary variable now? We're making comparison to our temporary variable now, because we know that the element at j was greater than I, so we've replaced the element at j at I with the element at j. So now, is the element at j greater than our temporary variable? In this case, yes. So the element at j is incremented by 1, and our whole comes down 1, is decremented by 1. So 12 now goes here, and the question mark now goes here. And then j is decremented again, decremented by 1. So is the element at j greater than our temporary variable? In this case, no, that is not true. So it's safe to say that j plus 1, we can store the temporary variable at j plus 1, because the element at j is not greater than our temporary variable. All right, and so each time through the inner loop, we reset j, or each time through the outer loop, sorry, we reset j. So now I is incremented. I now becomes 2, and j becomes 41. And we extend our sorted array. Remember, we are constantly extending our sorted array. So now we have a new variable inside, or we have a new value inside of our temporary variable. Now we hold 2 inside of our temporary variable. Is the element at j greater than the element at I? In this case, yes, it's true. So as you can see here, if we didn't store 2 or the element at I inside of our temporary variable, we would automatically lose it, because we are overriding it. There's a possibility that we may override it with the element at j. So now, hypothetically, j becomes a question mark. And now we decrement j by 1. So is the element at j greater than temporary variable? In this case, yes. So we move the element at j over 1, scoot it to the side 1, and now our question mark, well, let me erase this entire thing, it looks ugly. Now our question mark is decremented by 1. The question mark is here, and j is moved down 1. So we make another comparison. Is the element at j greater than our temporary variable? In this case, yes again. So override the question mark, move our element j over 1, and our question mark is moved here. And we move j over 1. So we'll make another comparison. Is the element at j greater than our temporary variable? In this case, yes again, 8 is greater than 2. So, as you might have guessed it, 8 is moved over. Question mark moves to here. So now j is now -1. Sorry about that. Now j is outside of the bounds of the array, and there are no more comparisons that we can make. So we're going to say j plus 1 is equal to our temporary variable, because again, we're outside of the array. There's no elements to the left of j that we can compare to the temporary variable. So safe to say we are at the end of the array and we can safely place 2 at j plus 1. And so we increment I again as j is reset. Increment I, j is reset. Our temporary variable is changed because I is now 6. So, and sorry, I forgot to increase the scope of our sorted array. Each time we're increasing the scope because the elements are being moved into the sorted parts. So we're increasing the scope. So is the element at j greater than the element at I? In this case, yes. So we override the element at I with the element at j. 6 becomes 41, and 41 becomes a question mark. And then j is decremented by 1. So now j becomes 12. And we make a comparison. Is the element at j greater than our temporary variable? In this case, yes. So again, we're constantly moving j over if j is greater than temporary variable. We scoot it over 1. Scoot it over 1. And now our question mark is moved over and j is decremented. So now j is here. So again, while j is greater than or equal to this first element, we're going to continue to move it down if that is true and if j is greater than our temporary variable. So in this case, we make the next comparison. Is j greater than our temporary variable? In this case, yes. So again, we move it over. We are constantly moving over and comparing. That's all we're doing. 9 question mark and j is decremented. So now j is here. So we'll make the comparison. Is the element at j greater than our temporary variable? Yes. Same thing. Move it over 1. 8 question mark. And now j is decremented. Now j is at 2. So is the element at j greater than our temporary variable? Is 2 greater than 6? In this case, no. So all we have to do is say j plus 1 is equal to our temporary variable, because we know that it is at its correct position. Since we moved all the greater elements over to the right, we can safely say that we can place j here, and it's sorted. As you can see, it is sorted because it's right in between 2 and 8. 6 is right in between 2 and 8. So I is incremented, j is reset, and the scope of our sorted array is increased. And now let's reset our temporary variable to I, the element at I. So now we've got 20 in here. This was supposed to be in black, but all right, that'll work. So is the element at j greater than the element at I? Yes, it is greater. So same concept. We override the element at I with the element at j. So 41 is moved here, and j becomes a question mark. I'm sorry this is taking so long, but I want you guys to understand the concept behind insertion sort. And now we decrement j. So now j is over here. So we compare j to the temporary variable. So is the element at j greater than our temporary variable? In this case, no. So again, it's safe to say that j plus 1 is equal to our temporary. We can store the temporary variable inside of j plus 1 because we've moved all the greater elements to the right. And now we're comparing it to the smaller elements, which are to the left. And in this case, it fits right in between 12 and 41. And as you can see, we increase the scope of our sorted array, and now everything is sorted. Since we've reached the end of the array, we don't have to do anything anymore. And now all of our elements are sorted, as you can see here. So that is how insertion sort works. Now we're going to write some pseudocode implementation for insertion sort. As you can see, 2, 6, 8, 9, 12, 20, 41. They're all in the correct order. So now let's go ahead and write some pseudocode implementation for insertion sort. So, oops. Let me get rid of this. Let's go ahead and switch this. All right. So we're going to write our outer loop first. So we're going to say for, I want to set I equal to 1, which is the second element in the array. Remember, I was always 1 greater than j, and j was always 1 less than I. Same thing. I equals 1, while I is less than the length of the array. So we're just going to say a dot length. We want to increment I plus plus. So now we enter this for loop. We enter inside of this for loop. We're going to set the temporary variable to the element at index I, which is what we were doing all along. And we want to set j equal to I minus 1. Because remember, j is 1 less than I. That's what I minus 1 means. That's all it means. So now we're going to say, I hope I have space here. We're going to write our inner for loop now. While j is greater than or equal to 0. So remember, while j was greater than 0, we were always decrementing j and making comparisons. While j is greater than or equal to 0, and that's an and sign. And the element at j is greater than temp, greater than our temporary variable. We want to enter this while loop. So let's go ahead and jump into this inner loop. We're going to set a of j plus 1 equal to a of j. So we're going to set the element at j plus 1 equal to a of j. So remember, we incremented the element at j, or we moved the element at j1 over, and we moved the question mark down 1 if it was greater than our temporary variable. So that's what this line of code means. And so we want to continuously decrement j while this is true. And after we break out of this inner loop, we want to set a of j. When it's false, we want to set a of j plus 1 equal to temp. So again, remember how I went out of this while loop, or out of this array, and j was here. Since there were no more comparisons I could make, I just set the element at j plus 1 equal to it. So now let's go here. Let's see. So now we're closing our for loop. I don't know why this isn't working. We just want to close our for loop. And that's the basic implementation for insertion sort. Now we're going to jump into Visual Studio here, and we're going to work this out in code, so it's a lot cleaner than what I have here. All right, so let's go ahead and jump into Visual Studio. And I'm going to explain it in Visual Studio as well, so no need to worry. All right, so let's go ahead and create a new project so that we can implement the pseudocode that we wrote. Let's call this Insertion Sort code. Insertion Sort code. You can go ahead and hit create. And so I'm going to go through each step of the code that I write, just so you aren't lost. All right, so the first thing I want to do is I'm going to create the array that we had, the unsorted array that we had. So let's go ahead and do just that. So, and let's just call it random array new, and I'm going to use object initialization syntax just so we can store the numbers directly. 12, 8, 41, 9, 2, 6, 20. Those are the numbers that we had. So we're first going to write out all these numbers unsorted. All right. So before insertion sort, we use a for each loop just to make it easy, make our lives a lot simpler. For each for unsorted and random array. Let's go ahead and use string interpolation here. We are going to unsorted, so write a comma after. So let's go ahead and run this code, and you're going to see that it prints out all the unsorted numbers. So as you can see here, the exact array that we have in our code before it's actually sorted. So now let's go ahead and create our insertion sort, which is why you're here. So declare a public static method. We're not returning anything. Let's call it insertion sort. Keep things simple. And inside of this function, we are going to take in an array. We are going to modify this array. So let's go ahead and we are going to initialize our temporary variable and the j variable. We're going to initialize those two variables. So we've got int temp, int j. So let's go ahead and initialize the for loop. We're declaring the variables, not initializing the variables. We're declaring them because we haven't given any value to them. We're going to initialize the for loop. Int I equals 1. Remember, we set I equal to 1, which is always 1 more than j. And for as long as I is less than the length of the array, so we're going to take this array parameter that we pass in, I'm going to call the length property on it. So as long as that is true, we want to increment I. So this is the outer loop. And here we are going to we're going to initialize the variables that we created up here. So we're going to set temp equal to array I. I'm going to set j equal to I minus 1. Remember, I is always 1 less than, or j is always 1 less than I. So let's go ahead and write our inner loop. We're going to use a while loop. So let's go ahead and look at our conditions that we wrote in here. So while j, these two conditions over here, while j is greater than 0, greater than or equal to 0, and while the element at j is greater than temp. So while j is greater than or equal to 0 and array j is greater than the temporary variable. Because remember, we're constantly comparing j to the temporary variable that we had stored. And if it was greater, if j was greater, we would move j over 1. So that's exactly what we're going to do. We're going to set, as you can see here, a of j plus 1 equal to j. So that's basically moving j over. So array j plus 1 equal to, not caps, array j. What else do we want to do? We want to decrement j. We want to say j minus minus. We can say j minus equals 1, whatever it is. And we're going to jump outside of this loop. And while it's not true, if this is not true, we just want to set array of j plus 1 equal to the temporary variable. So this basically means that we've reached to a point where either j is outside of the array at the beginning of the array, outside, or the element to the left of j is less than a temporary variable. So that means we would set j plus 1 equal to temp. So let's see here. If we had 6 here and 2 here, would decrement j, would compare 2 to 6, and we would switch 2 and 6. We would write 6 in here and 2 in here, as we see here. So let's check and see if this works. So let's go ahead and console.write. Console.write line first. Console.write after insertion sort. After insertion sort. I'm going to use a for each loop again. Each var sorted in random array. We want to console.write line or console.write each variable. I want to print out each variable. And again, we're going to use string interpolation here. Sorted. So now let's go ahead and see. Moment of truth. Oh, that looks ugly. I'm supposed to do this and some space. All right, here we go. Much better. Okay, that we forgot to call insertion sort on it. That's my bad. So insertion sort. It would have been smart to do that first. On random array. So here we go. Now it'll work. As you can see here, the numbers are in order. So we've got before insertion sort, the unsorted array, and after insertion sort, we've got this entire sorted array, just as we have it in our pseudocode implementation. And let's go ahead and try to add some more numbers in here. Let's say 1,000, 15, 10. Let's even include 0, 500, 45, 78. And let's go ahead and run this again. And it still gets it right. So we've got before and we've got after, 0, 2, 6, 8. And it's all sorted. So our code works. I hope you guys really liked this video. I hope it made sense to you guys. I hope everything I said kind of clicked in some way. If it didn't, please leave a comment down in the comment section and I'll be sure to get back to you. I'll try my best to explain it to you. Hopefully I did a great job. If you liked the video, be sure to hit a like. And if you want to stay tuned for more, I'm going to be bringing some more algorithms to this channel. Be sure to subscribe and hit the notification bell so that you're notified when I post a video. All right, be sure to subscribe and show some support and hit the like button. You'll have a good one. Thank you very much for everything. Thank you for watching. Have a great day. Thank you.